So, guys, we had looked at graphs of linear motion, and that is velocity time graph. Now, let's look at another concept, which is equation of linear motion. Equation of linear motion. Is that okay? So now we are going to try and then brainstorm together and then look at the equations of the linear motion. So, and then we can say from the definition of acceleration, as say acceleration is the rate of change of velocity. Is that okay? So we said that we define acceleration as the rate of change of velocity. So therefore we can say that consider a body moving initially with the velocity u accelerating at a uniform rate of a meters per second squared in time t to attain a maximum velocity v after covering a distance of s. Is that okay? So we are saying that consider body moving initially with the velocity v, u, the body initially was having velocity u, but it decided to increase the velocity or to accelerate at a rate of a meters per second for a given time t, and then for that time t it acquired a maximum velocity of v after covering a distance distance s. And then we say that acceleration is the change in velocity divided by time. So we shall say it is v minus u divided by time. That is the definition of acceleration. The change in velocity divided by time. Now, from here, if I decide to cross multiply, I will really say this is at equal to v minus u. And then if I take this one this side, I will say this is at plus u equal to v. Rearranging this, I can write as v equaling to u plus a t. We call this one equation 1, which is the first equation of motion that we are talking about. It is the first equation of motion for a body moving in a straight line. Is that okay? And then from the same statement, we can say from average velocity equaling to displacement divided by time. That means that will be equivalent to the displacement s divided by time t. Is that okay? And then I can put this equation in maybe star for average velocity. Average velocity. And then I can say also, okay, it is also known that average velocity can be given by the average of the initial and the final velocity, which is u plus v out of 2. This is equation star 2. Is that okay? And we are saying that average velocity is equaling to this. At the same time, average velocity is equaling to this. What does that mean? It means that equation 1 is equaling to equation star 1 is equal to equation 2 stars. And what does that mean to us? It will mean that I'll say S out of t is equaling to u plus v out of 2. Is that okay? And now from here, interestingly, we can now say S equaling to u plus v out of 2 times t. And then I can now call this one equation star 3. Is that okay? I can call this one equation star 3. And then I can say substituting equation 1 in equation star 3. Okay? So I will say now here will be S equaling to u plus. Where there is v, we said from equation 1, v is the same as u plus a t. So I will say that is the same as u plus a t out of 2 and then into t. And then this will imply that I have S equaling to, this is the 2u, and then I also multiply this inside at the same time. That I say it is 2u, with that t it becomes t, plus this one becomes now a t squared out of 2. Is that okay? And then this will be S equaling to 2ut out of 2 plus at squared out of 2. On simplification, this will lead me to S equaling to ut plus a half at squared. I call this one equation 2, and it qualifies to be the second equation of motion. Is that okay? This is the second equation of motion. So now let's look at how do we now continue from here. How do we actually continue from here? We are going to continue by saying from equation 1 making t the subject. From equation 1 making t the subject and substituting in equation star 3. In equation 3 stars. Is that okay? So that means that let's go to equation 1 and make t the subject. I will therefore say t equaling to v minus u out of a. That is when I decide to make, if I decide to make t the subject from here by bringing this the other side, after it going, I divide through by a both sides. It will take us there. So try making it the subject. We said after making it the subject, we substitute in equation star 3, and equation star 3 is here. So what does that mean? That means that we can now easily say here S equaling to, this is u plus v, which can be written as v plus u. There is no problem with the addition. 2 plus 1 is the same as 1 plus 2. Therefore, I'm right to change the order there. And then out of 2. Then it. We are supposed to say times t, but now our t is the same as v minus u out of a. Is that okay? And now that will give us S is equaling to v plus u into v minus u out of twice a. Is that okay? And here I think I can cross multiply here. Clear? And if you look at v plus u into v minus u, that one is exactly difference of two squares, isn't it? That is difference of two squares. And if I multiply this, I will say this is the same as 2as equaling to the product of this 1 times that, which is the difference of 2 squared v squared minus u squared. So if I now decide to take this the other side, it will become 2as plus u squared equaling to v squared. When I rearrange this, it will end to v squared equaling to u squared plus 2as. And I call this one equation 3. Is that okay? And now it is very true that the equation we have been naming 1, 2, 3, they are the very equation we are calling the equation of motion. Is that okay? So we can say in our conclusion that the equation 1, 2, 3 are called the equation of the equations 1, 2, and 3 are called the equation of linear motion. Is that okay? So the equation we have derived there are the equation of linear motion. So let's meet in the next episode and see how we can apply them.